It can support up to 2000 manage.
Can support one vManage can
In
support up to. Okay,
six vManage in one cluster. We can have
very
up
good.
to.
After that, second component.
Second component vSmart or controller.
First component is vManage. Second component is vSmart.
vSmart or controller
Tell me about
or
vSmart
controller.
now. Yes, controller. vManage or manager. Tell me about vSmart or controller.
Uh, I mean, it's a control plane component, right?
Yes, very good. Control plane component.
Manages
It distribute
it
and
manages
distribute the control plane information to manage devices. Through which
yes,
protocol?
OMP protocol,
Through
overlay management
OMP
protocol.
protocol. Very good. And then third one, third component, vBond or validator. Tell me about
Validator,
validator.
vBond or validator.
Tell me about vBond or validator.
First point of authentication.
First point of authentication. Okay.
Is a distribute list of vSmarts and vManager to all managed routers.
Okay. Do you have idea about like how this is first point of authentication, how vBond is going to authenticate the vanished devices or SD-WAN devices?
First is any public IP configured in vBond only.
Okay.
Once vManager or vSmart any device is connecting up, automatically DTLS run is erased.
How vBond or orchestration plane or validator is going to authenticate the SD-WAN devices by using certificate.
Oh,
Certificate, right? You know about certificate or whitelist? Is whatever website we have, for an example, google.com or pmnetworking.com. Every website is using certificate, right? Some kind of certificate, one certificate for the authentication, right? And generally, we are using third-party company for the certificate. For an example, if I will talk about pmnetworking.in, my website, or google.com, google.com. So here you can check the certificate.
Mm,
See, connection is secure. What it's saying, connection is secure, certificate is valid. And for the certificate, I am using third party company issued by R11. Right? Let's encrypt. Is the organization. Is the organization who provided me the certificate for authentication. Who is my organization? This is third party organization. Let's encrypt. For the google.com, in the same way, here if I am going to open google.com, so you can check the certificate. Here also you can see certificate is valid. And who is the organization? Issued by Google Trust Service,
Google Trust
WR2,
Services.
right?
Okay.
So we can also here we can use third party certificate for the authentication. So we need to install that certificate on all devices, and my vBond is going to check that. My vBond is going to validate that. It is similar like the passport office. Who is going to issue the passport, guys? How your passport is valid? I can make duplicate passport as well, right? But is that passport valid? when I will travel outside, they can easily understand that this is not a valid passport. How? Because who is going to issue the passport? Government, passport office of
Government,
government,
some
right? And they guys are going to sign on your certificate. They are going to sign, right? So if there is sign of government, that means certificate is valid. If there is no sign, that means certificate is not valid, right? For an example, on your passport there is one certificate key, ABC123, right? So all the governments have one centralized server where he is going to update your passport. He is going to make the entry that this key is valid, and whenever you are going to travel outside, they will just see your passport. They are going to put the key in the on the website, and they will check is it is valid or not. So there is sign of government, and you have a unique number. In the similar way, in SD-WAN also we are going to use the certificate. By the way, here when we will perform lab in the EVNG, then we have to take care about the certificate also. But what I told you, in the real time, this is not our concern. In real time, when we will purchase the SD-WAN solution, let's say from the Cisco or Versa, from any provider, right? We don't need to configure the certificate there. But here in the EVNG, we have to configure it manually. So first step of your SD-WAN lab is going to be installing certificate only. And two types of certificate we need to install. See, even on the passport, there are two types of identity. One is government identity, the key number and sign, and one is your identity, your name, right? Your father name, your contact details. In the same SD-WAN, all SD-WAN devices are going to use two types of certificate. One is called root certificate. Root certificate is similar like sign of government, and identity certificate. Another one is, second one is identity certificate, which is your identity, right? So each devices will have their own identity with sign of a centralized server, right? In the lab or even in the real time also, see, for the certificate either I can pay to third party company, or I can set up my own enterprise server. I can set up my own enterprise server where I can install the certificate. I can configure CA server. When I can use a router for the CA server, I can use Windows server, right? That will be my enterprise server, right? I will connect it somewhere in the network, maybe in data center, right, at the centralized location, and all my websites, devices who need certificate will request to the enterprise server, to the CA server, and then CA server will issue the certificate. Similar thing we are going to do here in the tab for SD-WAN, right? So either I can use a Cisco router, right, where we can configure, where we can enable CA server, or we can use a Windows server. Windows 2019, you can use whatever Windows server you have, right, in your EVNG. By the way, in my EVNG, one Windows machine is also available, router is also available. You can use anyone. Fine. In the real time, maybe third party company is responsible for certificate, right? So your issuer who is issuing the certificate is third party company, or maybe you are using enterprise server, or maybe Cisco is providing the certificate. Okay, so vBond is responsible for authentication. vBond is first point of authentication. How you can remember the vBond or validator or orchestration plane? You can say vBond authenticate SD-WAN devices by using certificate. And then is the another function of vBond, that is for first function. First function is validation, right, authentication. Second function of vBond is providing the IP address of your vSmart and vManage to manage devices. For an example, this is my site. One site where I have managed devices, two managed devices. Okay, connected to, for an example, internet. Internet, and on the internet I have somewhere vBond. This is vBond, and the IP address of vBond is, for an example, 100.1.1 is the IP address of my vBond. Even in the SD-WAN, you are going to learn ZTP process, zero touch provisioning, means your router can automatically get the IP address of vBond 100.1.1. Okay, so either I can tell to my router who is your vBond, or my router can automatically resolve the IP address of vBond. But guys, these WAN edge devices first need the IP address of vBond, right? Once my WAN edge devices will get IP address of vBond, it is going to send some kind of message, hello message, for an example, right, to establish the tunnel. SD-WAN is overlay technology. First of all the devices are going to establish a control connection, either by using DLS or TLS protocol, DTLS or TLS protocol. We have two protocol for control connection. One is UDP based, one is TCP based, and by default protocol is DTLS. So by using DTLS protocol, both WAN edge devices are going to establish a control connection with vBond, and then vBond is going to authenticate them. If these two devices are valid, right? If these two devices are valid, then vBond is going to share IP address of vSmart and vManage, right? At the end, my WAN edge devices need IP address of vSmart and vManage only. These devices need who is my vSmart, so that I can connect to vSmart and I can share the prefixes, and who is my vManage, from where I can take the configuration. So who will give the information of vSmart and vManage to WAN edge devices? Your vBond, right? So the another function of vBond is it distribute the list of vSmart and vManage to all WAN edge devices. Distributing the list of, if we have multiple vSmart, then the information IP address of all vSmart and all vManage will be distributed to WAN edge devices by vBond. Clear? And always keep in mind, in SD-WAN, the first thing is your vSmart. Your vSmart should be publicly reachable. Your vSmart should be publicly reachable. Because on my WAN edge devices, just I am going to tell who is your vSmart, that's it. After that, all the process is automatic. We are not going to configure anything else. Automatically my WAN edge devices is going to find vSmart. Automatically my WAN edge devices is going to establish OMP session with vSmart, and automatically my WAN edge devices will find vManage, and it will take the configuration from there. Only thing which we are going to configure on WAN edge devices is the IP address of vBond. Who is your vBond? For an example, you are the WAN edge devices. You need vBond IP address so that you can get to know about your controller, about your manager. But before distributing the IP address of vSmart and vManage, vBond is going to authenticate it. It is going to check the certificate, and whatever sign is there on the certificate, the sign should be exactly same. If sign is different, then vBond will never provide or distribute the IP address of controller. Right? Practically, we will see all the things step by step. Don't worry. This is just basic idea. So that's why I'm saying vBond should be publicly reachable, and every time vBond will be, guys, publicly reachable. If my vBond is inside the network, let's say I have here data center, and in my data center I have deployed the vBond. So how I will make my vBond reachable from the internet? If here is my V bond, right? Then what we can do on edge devices, here I can have one firewall, I can have one router, and here I can configure a static NAT, correct? A static NAT. And through a static NAT, again my V bond is publicly reachable. Maybe V bond is using private IP address, but it is publicly reachable because of a static NAT. Because here the IP address is public, let's say 1.1.1, and the V bond is using private IP address for an example 10.1.1.1. Right? So this firewall or WAN edge device router will translate 10.1.1.1 into 1.1.1.1. Whenever someone will hit to this IP address, my WAN edge device will forward traffic to V bound. So doesn't matter how your V bound is reachable, through NAT or through the public IP address, but it should be publicly reachable. That is my first requirement. From any WAN edge devices, your V bond should be reachable. You should be able to ping your V bond IP address. Clear? So I will talk about the lab, guys. So I have already one lab, but we can do one thing. We can create another lab also. Because in my lab, I think I am using directly public IP address 192.168.1.5. Yes, you can see in my case, vBond is using public IP address 100.1.1.3. So I don't need to configure NAT here. Okay, or you can use the private IP address over here, and then you can configure NAT on this switch, router, firewall. Okay, then we talked about next component. What is the next component? Fourth component,
VH.
WAN is device. It can be my case or
CH.
CS or CS. VS means Viptela is, CS means CoAs. Now guys, where I can deploy these devices. First of all, let's talk about deployment of these controllers. Where I can deploy it. Just give me 1 minute. Yes, guys. If I will talk about the deployment of this controller, this software, so I have two options. Either we can deploy it on our own server, on premises, right? I can purchase a server, I can place that in data center, and where I can install these all software. First option. Second option, if you are going to install it on your own server, on premises, which type of software is required for on premises? Either we can install vSphere, or we can, vSphere means ESXi, many of you know, where I have also installed the software. And the another option I have is KVM, or next option is cloud. Next option is cloud. On the cloud also we can deploy it. Either we can deploy it on premises, or we can deploy it on the cloud. So we have multiple cloud provider like AWS, Azure, GCP, Cisco, right? You can purchase any cloud service, means you can rent the resources, whatever resources required to run these software. And now if I will talk about the managed devices, so again in the last class I told you we have CS. So CS means Cisco edge devices. I can use ISR router or ASR router. If I will talk about ISR, so ISR 11,000, 1,000, 4,000, right? ISR 4,000 routers, ASR 1,000 routers. We can use these routers for CAs. Or if you want to use cloud, in cloud like virtual appliance, so you have CSR 1000 V. Can use this router. These are CSs. And for VSS, again, these are the hardware, physical hardware. And this is virtual appliance. So virtual appliance can be again installed either on cloud or on premises, on our own server. And if I will talk about the VS, 50 lines, so we have VH 100, we have VH 1000, we have VS 2000, 5000, or VS Cloud. VS Cloud. Right? So these are again hardware, physical hardware. And VS Cloud is again virtual appliance which can be installed on our server or over the. So this is the deployment. And these are the components of SD-WAN. Hope it is clear to everyone. If anyone have question from these topics, please ask. About the component, you should have basic idea about it. What is vManage, what is vSmart, what is vBond, what is CS, what is vEdge. Many of you already know how Cisco devices looks. Let me show you how VS devices looks like. So you can see these are the devices. Quality VS1000. Which device it is? Viptela VS1000, right? We have again guys similar ports like Cisco devices, management port, console port. Can anyone tell me the difference between management port and console port?
Yeah, console is for physical access and management is for remote.
Through management also we can have physical access. No, sorry, let's say here I have the PC. I can directly connect the management port to PC. Direct access. Through management, you can access this device either through CLI, through SSH, or through GUI.
Yeah.
Through console, we can only access it through CLI. GUI access is not possible over console port, right? And what is the function of this port? This white square port. This is also RJ45 port. This is also a console port. This one is also console port. Then some USB ports are there. Again to access the devices. Let's say you have the console cable with serial port and serial port is not available on your laptop. Then how you will access this device? Because through management port, when we can access the device after the initial configuration. Guys, if this device is dummy, right, just I have purchased it. Even we didn't configure the IP address on the management interface, then we cannot access it through management port. For the initial configuration, I need console access only. And the serial port is not available on my laptop. So here we have USB port to access it, right? Then some LEDs are there, system, status, power 0, power 1, right? Some SAP LED, because these are the SAP ports. Through these ports we can connect LAN and WAN. Okay, so device is exactly same like Cisco routers, similar to Cisco routers. So either we can deploy this device on our sites or we can use VS Cloud. In the lab we are going to use VS Cloud, but operating system of both the devices is exactly same. So the configuration is going to be guys exactly same. This is hardware, physical device. Okay. Even if you need to deploy this device on site, directly you can connect it to WAN, to ISP. That's it. Your device can load the configuration automatically. Your device can resolve the vbound IP address automatically. Automatically it will resolve the vbound IP address. Automatically it will load the configuration from vmanage. It will establish all the control connection, OMP session, BFD session, whatever sessions are here. And device can be live within 5 to 10 minutes automatically. That process is called ZTP, zero touch provisioning. We'll see it. Okay.
So no need to do any
No
configuration
need to do any
when
configuration,
I
nothing,
connect it.
nothing. Just purchase from the market and connect it to LAN and WAN. That's it.
Okay, ISP port, which port we can connect any one of the SAP port?
Any port, yes.
Any.
One port you need to connect to WAN,
So
one port to LAN. That's it.
we don't have any WAN port like that.
No. In the router, if you have two port, fast Ethernet 0/0 and 0/1,
Mhm.
right? So
So
either I
these,
can connect 0/0 to ISP internet or 0/1 to ISP. Similar way we have these ports. We can use any
Any
port for
okay,
WAN, any port for LAN.
okay. Here 8 ports. So how we can identify this one is WAN port or this one is LAN port? Eh, do we? Is there any separate identification we need to do?
How you will identify the LAN port and WAN port on the Cisco router?
Okay. Okay, fine. I got it now. So we have normally we have 4 ports or 2 ports in that router, but here we have 8 ports. All are connected into one side is connected to service provider, one end is connected to LAN, our enterprise network. I got
Yes.
it now. Yeah, yeah.
Any other question?
So these edge devices are connected to directly end users, or in between there is any other
You
devices
can directly
between, I
connect
mean,
PC here also. You can connect switch here. You can connect router here, firewall here, any device, any networking device. This is similar like your Cisco router, brother.
okay. But
These
in the
physical
WAN
ports are
environment, it is the
exactly
edge. I mean, but in the WAN environment, it is the edge device. I mean, you can consider. Right?
I didn't get you.
But in the SD-WAN environment, this is the edge device, right? I mean,
Yeah, edge device similar like Cisco routers.
okay.
Operating system is going to be different. Right? The physical appearance is exactly same. Like on the traditional Cisco router, we have fast Ethernet link, gig link. Right? Similarly, I have these ports here. On the Cisco
Yeah.
router, if I want to connect fiber cable, I am using what? SFP? We are using SFP. First, we'll insert the SFP on the fast Ethernet link, and then we can get the fiber cable. Because by default ports are RJ45 ports. Here on this WAN devices directly you can have SFP port. You can change this module also. If you want Ethernet port, you can change the module.
Okay.
The physical appearance is exactly like traditional Cisco routers. Okay, nothing is different here. So these are the components. Now guys, the most important thing of SD-WAN. For an example, this is the internet. Internet. On the internet, here is my keyboard. And this is not sure like vBond, vSmart and vManage. All the controllers should be at same side, right? Even you can install vBond in your home as well, right? Maybe my vBond is installed in my home through internet and I have configured public IP address over here. So my vBond is reachable from internet, or I can deploy it on cloud. If I have deployed on cloud, then also it is reachable through internet connection only. Then also it is reachable through internet connection. Cloud services guys reachable through internet connection, right? If you have internet connection, you can access your all cloud service with the fine. And two sides are there. I have two side here. Side one, side one, side two. Both the sides are connected through And maybe on the internet only somewhere I have vSmart. Right now I'm not talking about vManage. Forget about vManage. This is my vSmart, and here I have one router. Let's say this is VS1, and here I have another VS. So what I told you, first of all, your VANage devices need IP address of vBond. vBond IP address is 100.1.1.1. Once I will configure vBond IP address on VS1, what will happen? It will establish one control connection by using which protocol? By default DTLS, but you can change it to TLS also. Why by default DTLS? Because guys, you know UDP is faster than TCP. vSmart IP address is 200, right? So it will establish one control connection over here. Control connection, DTLS connection, right? And doesn't matter how many transports are there. Maybe I have internet and MPLS between VANage and vBond, right? Over all the transport, it is going to establish one DTLS connection. This is INET, internet. And after that, vBond is going to validate it, and then it will share the IP address of vSmart. IP address of vSmart and vManage. For now, let's talk about vSmart only. So my vBond is going to tell the IP address of vSmart is 200.1.1.1. Now vSmart already know who is vSmart and who is vManage. What is the IP address of vSmart? What is the IP address of vManage? And once my VANage devices will get IP address of vSmart, which is 200.1.1.1, it will try to establish DTLS connection with vSmart. It will establish DTLS connection with vSmart here. Similar way, VANage 2 will also first establish DTLS connection with vBond, and this DTLS control connection is temporary. Once VANage devices will get IP address of vSmart and vManage from the vBond, it is going to break this control connection. But the control connection between VANage devices and vSmart is going to be, guys, permanent. Or control connection between VANage devices and vManage is also permanent. First of all, in the lab, we are going to verify the control connection only. Right? So similar way, both the VANage devices will have IP address of vSmart. That this VANage 2 also know who is vSmart. vSmart 200.1.1, and this VANage device also know who is vSmart. 100.1.1. Now both the VANage devices is going to establish DTLS connection with vSmart. And you know DTLS and TLS control connection is, guys, fully secure, because all the traffic which is going to flow inside this connection is going to be encrypted, right? So this control connection is fully secure, and SD-WAN will work over this control connection only. This is similar like tunneling, overlay, right? And inside this control connection, automatically both the device, VANage device and vSmart, is going to run OMP protocol, overlay management protocol. So on VANage devices, you can check who is your OMP neighbor peer. So it will show you OMP peer is vSmart. Do I have any OMP pair between VS1 and VS2? No. right? Both the WAN is, all the WAN edge devices will have OMP pairing with vSmart only. And now here if I have on LAN 10.1.1.0/24, right? So my WAN is one is going to advertise this LAN subnet to vSmart through OMP protocol. OMP is a routing protocol similar like OSPF. This routing protocol, but more than routing protocol, right? Routing protocol advertise only routes. OMP also advertise routes, but OMP advertise some more information than route as well, right? And what will happen when vSmart is going to receive this LAN subnet 10.1.1.0/24 through OMP? Definitely it will advertise to their another neighbor to WAN is 2, and this way side 2 will learn side 1 prefix. If here I have one LAN 20.1.1.0/24, WAN is 2 is going to advertise it to vSmart through OMP protocol, and vSmart will advertise it to other side. So through OMP, LAN prefixes is going to be exchanged between two sites. Is it clear? Now our next topic is going to be OMP only, guys. We are going to first master the OMP protocol. Okay, clear? Any question till here? So if I have two WAN edge devices, WAN is 1 and WAN is 2, and between the WAN is side 1, side 2, I can have any transport, that also doesn't matter, right? It can be MPLS, it can be internet, metro ethernet, these line 4G, 5G, any transportation is there, right? First of all, between WAN edge devices to the vSmart. Here in between we have vSmart, and both the WAN edge devices is going to establish OMP session. OMP session with vSmart. WAN edge 2 is also going to establish OMP session with vSmart. And through the OMP, it is going to exchange the routes. This is for control plane, right? If I will talk about the data plane, guys. So for the data plane, both the WAN edge devices is going to automatically establish IPsec. Between WAN is 1 and WAN is 2, we will have IPsec session for the data plane. Through OMP, WAN is 1, know the route of side 2. Here is one LAN 10.1.1.0, 10.1.1.0/24. So through OMP, side 1 is going to learn it 10.1.1.0/24. And when user is going to forward traffic in this subnet, then how traffic will go? The data plane through the IPsec. Through IPsec. Right? So for the control plane traffic and management plane traffic, we have control connection, all the control plane traffic and management plane traffic. Plane will travels through control connection, to the control connection, right? And all the data plane traffic, for data plane, all the data plane traffic travels to IPsec. That's why I'm saying SD-WAN is fully secure infrastructure solution. Clear? But guys, to establish OMP session or control connection with VSmart, WAN edge devices need first IP address of VSmart. Who is my VSmart? And who will provide the IP address of VSmart? Your validator, your controller. Even V bond or your validator is responsible for one more task, that is NAT transfers. That is NAT transfer. For an example, in branch 2, let's say, in branch 2, WAN edge devices, I'm using private IP address. This WAN edge router is connected to one firewall. This WAN edge devices is connected to one firewall here. And on the firewall, I am using public IP address, and on WAN edge devices, I am using, on WAN edge devices, I am using private IP address, and on my firewall, I am using public IP address. Right? So when WAN edge 2 is going to advertise this LAN subnet 10.1.1.0, next hop IP address is going to be private. But WAN edge 1 cannot reach to WAN edge 2 site 2 through private IP address. So in that case, vBond is going to help to know the public IP address of site 2. And that is the concept of NAT transfers. We'll see those all things in upcoming days. Don't worry. So if I will talk about the connection only, the default connection in SD-WAN, how many types of connections are there? All the control connection. Right? So we have two types of control connection here. One is temporary control connection. Temporary control connection between guys, between vBond and
VH.
WAN edge. Right? Second one is permanent control connection. Control connection between WAN edge to VSmart. Then VSmart to vmanage to manage. This is a permanent control connection. Now, if I will talk about IPsec, so we will have IPsec between WAN edge devices. Only WAN edge devices. Between two WAN edge devices, we will have IPsec. If I will talk about the OMP session, so we will have OMP session between WAN edge and smart. And between WAN edge devices, we will have IPsec as well as BFD session. BFD, right, which is the link liveness protocol, which is used to measure the quality of link. BFD, we are using BFD protocol in traditional networking also with OSPF sometime on the WAN link, right, to measure the jitter, latency, packet loss. Similar way, we will have by default BFD session between the WAN edge devices to measure the quality of WAN. So now I am going to first start OMP protocol, and then guys will verify all the control connection. Or another option is first we can verify all the control connection and then I will start OMP protocol. So you tell me. You tell me from where I should start. First OMP protocol or first you want to verify the control connection. Better to verify control connection after learning the OMP protocol. So let's start the first protocol of SD-WAN, which is OMP. So what I told you, OMP stand for? OMP stand for overlay
Overlay management protocol.
management. Right? Overlay means it is an overlay technology, means it will work on top of the physical network. Where it will work on top of the physical network. We can say it is Cisco SD-WAN protocol, right? It is routing protocol or more than routing protocol, which is used to exchange routes. It runs between when I am saying WAN is, it means I'm talking about either VS or CS
CH.
and V smart or
Way smart
between
no.
between if we have multiple VS Smart 1, VS Smart 2. So between VS Smart 1 and VS Smart 2 also MP protocol will work. Between the VS Smart or between vanished devices and right. So you know in the topology, generally I will have vanished devices. Let's say this is my vanished device. Vanish. I am going to connect my vanish to internet or MPLS. Let's say both the transportations are there, internet as well as MPLS. My vanish devices is connected to both the transport, internet and MPLS. And through internet or MPLS, I will find my controller, right? There is the controller for an example or VS also connected to as LS. So how many OMP session I will have on this vanished devices? Two. Two OMP session Yeah, one over internet and one over MPLS, or one OMP session, guys, will only have one OMP for both the transport. It is similar like DTLS connection. You first step is the IP address of VSmart. When VAN's device knows the IP address of VSmart or controller, it will establish DTLS connection.
Okay. So in our premises, we should have WAN edge as well as vSmart controller also. Both should be connected into that MPLS and internet. Is that correct? Or?
VSmart should be reachable. Doesn't matter where is the VSmart, right? Maybe this WAN is device is in India, Delhi, and VSmart is connected in US,
Okay, okay.
right?
So it should be in the vSmart, maybe in that headquarters or data center, and WAN edge should be in the branches.
Correct.
So we can form the connectivity between
Correct.
this.
Okay. So for an example, here I have one DTLS
Sir, what is
connection.
this?
What is?
Sir, I have doubt. What is the difference between TLS or DTLS connection, sir?
TLS is a TCP based protocol. DTLS is UDP based protocol. What is the difference between TCP and UDP? TCP is more reliable than UDP. That means TLS is more reliable than DTLS. UDP is faster than TCP. Means DTLS is faster than TLS. These are the differences. Whatever differences you know between TCP and UDP, all differences are there. Here also,
Okay. Okay, sir, got it.
right? So for an example, here I have one DTLS connection over internet, and I have one DTLS connection over MPLS. So over all the control connection, my WAN edge devices will try to establish OMP session. Guys, many more things are there which we need to discuss, which we need to learn. How WAN edge devices or controllers are going to identify the internet link or the MPLS link. So we have concept of T-log, right? And why we have multiple link here between WAN edge devices and VSmart, we already covered in the last class. For redundancy, for load balancing, for forwarding general traffic via internet and critical traffic via MPLS, right? Fault tolerance, load sharing, these are the reason of multiple transport. So here for an example, I have two DTLS connection, one over internet and one over MPLS, but you will have only one OMP session. It is similar like BGP. Hope you all know the BGP. Guys, if I have a scenario here, I have four routers, R1, R2, R3, and R4. Between router 1 and router 4, how many paths are there? R1, and let's say this is R2. R2 connected like this. On router number 1, I have one loopback, 1.1.1, and on router number 2, I have one another loopback, 1.1.1, and here I have one another loopback, 2.2.2. So, and I am running, let's say, OSPF protocol. So after enabling the OSPF, if all the links are same, let's say fast Ethernet link, all the links are fast Ethernet link, then 1.1.1 and 2.2.2 are reachable from both link, from both the path.
Yes, correct.
Correct. But when you will configure the BGP, how many BGP you will have BGP session? When I am going to tell to router number 1 that router BGP AS number 100 and neighbor 2.2.2.2, let's say remote AS 100. How many neighbors will be there?
So at the moment we should have so only one neighbors we have.
Only one neighbor, right? Doesn't matter how many paths are there between source and
We have two.
destination. That's not matter, right? We can have 10 number of path, then also we will have only one BGP session.
Correct.
In the similar way, we will have here one OMP session over all the control connection. Then we have 2 control connection, 3 control connection, 4 control connection. Control connection depends on transport. That is the equal to the number of transport. If I have 2 transport, internet and MPLS, I will have 2 control connection, but we will have only one OMP session. Similar like BGP here in this case. And if I am going to ask you that, okay, if there is only one neighbor of BGP, then BGP is going to use which path? Via R3 or via R4? Anyone know the answer of this question?
So it based on the attributes.
Based on the attribute. If BGP here, BGP sends their messages, let's say open message, first message of BGP, from which path BGP is going to send the message to their neighbor 2.2.2? Here write down kar lo aap, right? This is your question, okay? Find the answer of this question. I have enabled BGP between 1.1.1 and 2.2.2. And I am asking you, router 1 need to send BGP open message. From which path it will send? Via router 3 or via router number 4, or it will perform the load balancing. So we have exactly same concept over here for OMP. We will have here one OMP session. OMP over all the transport. Okay. So in this case, in our lab also, I have 2 transport, but let's say on in branch 1, side 1, branch 1 VS1. On this router, if you are going to check OMP session, you will have only one OMP session with okay. Guys, to enable BGP, after running this command, router BGP S number 100. First of all, BGP is going to elect router ID. Am I right? That is unique identity of BGP router, unique identifier. In the similar way, OMP also needs router ID here. But in SD-WAN, the unique identity of your devices, SD-WAN devices, is called system IP. Is called system IP. Right? So through system IP, OMP protocol is going to establish IPsec. Let's say system IP over here is 1.1.1.1 and system IP of my controller or VSmart is 2.2.2.2. So with the help of this system IP, OMP protocol will establish OMP session. System IP is not the IP address, right? Remember, BGP router ID or OSPF router ID is not the IP address, which is not routable. I can configure different router ID here also. I can say BGP router ID 10.10.10.10. You cannot ping to that IP address. In the similar way, system IP is not the IP address. It is not routable. Only the format is like the IP address. It is unique identifier of device. Right? And we'll discuss more about system IP in future video, don't worry. Clear? So here in the lab also, for now, I can verify it. Let's say I'm accessing any managed devices. And here if I will log in admin by default. This lab is guys already configured, right? But this is not your lab. Our lab will configure everything from the scratch, right? Here if I will check so OMP pair is not there. Just wait for some time. Devices are getting ready. Devices are not ready till now. So control connection we can verify. Control connection. And you can see we have control connection with VSmart, VBond, right? This is the error of simulation, right? What I told you, with VBond, vanished devices will have temporary control connection. But in the simulation in EVNG, every time you will see this session here, this control connection. This is the error of simulation, right? Soon we will have control connection with vManage also. Right now I don't have control connection with vManage. My vManage is still getting ready. Okay, it will. So for the guys, OMP single transport is also sufficient. For the OMP doesn't matter how many transports are there. Because it is going to establish, it is going to form only one OMP session. So using internet only or MPLS only is also sufficient. You can keep it in mind like this. Over all the DTLS or TLS control connection, OMP will form only one session. Single transport, single OMP session will be formed over all the available transport similar like easy. Once when this device will establish OMP session, it will advertise local network, the VSmart. And with the network, it will also advertise some additional informations like T-logs. Later we will learn about T-log. Later we will learn about service route. So OMP does not only advertise routes, it also advertise route, T-log, service route, and these all types of route we need to discuss. OMP advertise generally 3 types of route: OMP route, T-logs, and service route to the controller, to the VSmart. And after that, VSmart is going to calculate the best path like BGP. Whenever BGP is going to receive any update message, what will happen? First it will check the attributes, it will calculate best path, and after that it will install it in their routing table, and then it will advertise to their neighbor as well. So similar way VGP will VSmart will advertise it to another side. So again in the OMP we have lots of attributes like BGP, and we need to understand those attributes, right? Guys, for an example here, this WAN edge devices is connected to another router. And behind this router I have the LAN subnet. Behind this router I have LAN subnet 10.1.1.0 or 192.168.1.0/24. And between the router, this router and WAN edge devices I am running OSPF protocol. right? So OSPF and OMP both are different routing protocol. How we are injecting route in two different routing protocol? Through redistribution, right? So here also we have to perform what? Redistribution now. In this case, in my lab, you can see between managed devices and internal devices, I am running IGP protocol. So control connection, and now I am expecting control connection with vManage also. Yeah, now you can see vManage is there, and so OMP session. Who is peer? OMP peer 2.2.2. 2.2.2 is vSmart only. You can see the system IP of vSmart is 2.2.2. Right? So I have two control connection with vSmart. One over internet and one over MPLS. But over these two DTLS control connection, I have only one OMP. If I will give you the real time scenario, like in the real time, how it is going to be look like. So you have two WAN devices. WAN is 1, WAN is 2. Between WAN is 1 and WAN is 2, you know there are two transport, internet and MPLS. Like this. This side 1, side 2, side 2. Right? Here also we will have TLS connection. And here our MPLS also I will have TTLS connection through vSmart, right? So in this case, somewhere my vSmart, for an example, this is my vSmart, vSmart, inet, internet, and this. So our both the transport, what will happen? Side 1 is going to establish control connection here, DTLS. Over here also DTLS. And inside the DTLS control connection, it is going to form OMP. Yes, na? Here I have OMP. Here also I have OMP. Correct? And guys, inside one I have one LAN 10.1.1.0/24. Side 1, managed device is going to advertise it to vSmart. vSmart will advertise it to side 2. But when side 2 want to reach in this subnet 10.1.1.0/24, they can reach either through this public IP address. What should be the next hop? What should be the next hop for 10.1.1.0/24 in side 2? Either this interface IP address or this interface IP address, right? Right, guys?
Yes, correct. So maybe it should be site 1 or site 2.
I'm talking about side 1 LAN prefix on side 2. Side 2 have received the LAN prefix of side 1 through OMP. But to reach in this subnet, we need next hop IP address. And next hop IP address should be reachable from side 2. So here I will have public IP address, and definitely that public IP address will be reachable from side 2. Here I will have VPN and over the MPLS, and the VPN IP address will be reachable from side 2. Correct? So the first thing which side 1 is advertising to VSmart through OMP is route. And the second thing which side one is going to advertise to VSmart through OMP is next hop. And next hop in the SD-WAN is called what?
T-lock.
T
T-lock.
T-lock stands for transport locator. It is unique identification of transport, right? So for an example, T-lock of this interface is T-lock 1 and T-lock of this transport is T-lock 2. Lock, right? So side 1 is going to advertise this submit 10.1.1.0/24 with two T-lock. T-lock 1 and T-lock to the VSmart. And VSmart will exactly advertise both the T-lock and prefix to side 2. And now side 2 is going to perform best path selection by using attribute. What side 1 is saying, hey VSmart, I have this subnet 10.1.1.0/24 and I have T2 T-lock. T-lock 1, T-lock 2. You can reach to this subnet by using any one T-lock. Now you can decide which one you want to use. If you want to forward traffic through internet, then you can use T-lock 1. If you want to forward traffic through MPLS, you can use T-lock 2. But VSmart don't need this routes subnet because VSmart is not going to forward any traffic to side 1 user. VSmart is going to advertise it to other vanished devices. And other vanished devices is going to perform what? Best path selection. Right? Similar way here, if I have one subnet, LAN subnet, let's say X. So this side also have two T-lock, T-lock 3 and T-lock 4. So side 2 is going to advertise X subnet with T-lock, T-lock 3 and T-lock. Right, and VSmart will advertise it to other vanished devices. So this way, the vanished devices is going to receive two types of route through OMP from the VSmart. One is OMP route and another one is T-lock. If you don't want, see from the side 1, if you don't want to advertise T-lock 1, you want to receive all the traffic from MPLS only, you can stop advertising internet T-lock to the VSmart. Side 2 will never get T-lock of internet. Right? We have policies. Whatever you can think, you can configure over here. We have lots of options in the policy. Those are the only main beauty of SD-WAN. Even though these side users are not going to use this T-lock to forward the traffic, with the help of T-lock, like now side 2 have T-lock of side 1 and side 1 have T-lock of side 2. So with the help of this T-lock, my sites are going to now form IPsec tunnel directly. Now there is no involvement of VSmart here in the IPsec, and it will use this IPsec to forward traffic. But what is the requirement for the IPsec? T-lock. T-lock must be there. So once both the sites are going to receive T-lock, it is going to establish IPsec. Right, here also you can verify it. So IPsec. So IPsec on connection, and you can see between all the sites we have IPsec for data plane, right? There is no any IPsec with controller, VSmart or vManage or vBound, right? These are the IPsec between sites. For an example, between 7.7.7 and 4.4.4. So here is 7.7.7. This one is the 7.7.7. And here is the 4.4.4. WAN is device in DC. And here I have IPsec to forward the data. Right? So how it is going to receive these prefixes? Through VSmart. This VANED device is going to advertise it to VSmart. VSmart will advertise it to this VANED device. It will also advertise T-lock. And once both the sites will get T-lock of each other, it will establish directly this IPsec. And it will use this IPsec to forward the data. Now, how many IPsec session I will have between side 1 and side 2, guys? How many IPsec session will be there? Minimum 2 IPsec session will be there because I have 2 T-lock of side 1 at side 2. In the same way, I have 2 T-lock of side 2 at side 1. So for both the T-lock, I will have minimum 1 IPsec. By the way, there is concept of restriction. If you will not configure the restriction, even internet is going to try to establish IPsec with MPLS here also, like this. But there is no any connection between internet and MPLS. These two transportations are not connected, right? So there will be no route. Internet cannot establish IPsec with MPLS. And over the IPsec, inside the IPsec, it will automatically enable BFT. In the same way, if I have multiple VSmart, so between VSmart also, OMP protocol will work. Between VSmart. For an example, because of redundancy, I have 4 VSmart, VSmart 1, VSmart 2, VSmart 3, and VSmart 4. So between all the VSmarts, we will have OMP. Getting my point? And my vBond is going to advertise these all VSmart to VANED devices. The list of VSmart. Right? So hope OMP is clear. Any question in OMP protocol? Except T-lock, because now we are going to start the T-lock. About T-lock. Any question in OMP? Even we have not discussed best path selection of OMP. We will talk about best path selection later after talking about T-lock. Any question to understand OMP protocol? It is similar like your routing protocol. Can I move, guys?
Yes, yes.
Now, topic is T-lock question for transport. Transport. For an example, I have one VANED device and connected to transport. You can assume this is your router as well. A or one is internet. Every time using internet and MPLS, you can use another transport also, right? That's why in the yesterday class, first I told you what is the benefit of using both and why most of the companies are using both. One more thing you know over here, that is system IP, which is the unique identity of SD-WAN devices. So for an example, system IP of this device is 1.1.1.1. Now, the first thing which your vanished devices is going to perform over here is, after discovering the PS Smart, forming the OMP session, it is going to calculate the T-lock. T-lock of internet transport and T-lock of MPLS transport. How it is going to identify the transport? For an example, this is T-lock 1 and this is T-lock. So guys, T-lock is combination of three things. T-lock is combination of three things. See, if this vanished device is going to advertise any LAN subnet, let's say to the internet only. So how internet will reach to that subnet? Through the IP address, through their public IP address, which is running on VH, correct? Okay, if you are not able to understand, no worry. First, T-lock is combination of three things. T-lock has three tuples. First one is system IP. System IP plus color. Again, new word for you, Praful. What is now color? And third thing is encapsulation protocol. Encapsulation, which is by default IPsec over all the transport. But encapsulation protocol can be GRE or IPsec. That's why I told you automatically it will establish IPsec, because the encapsulation protocol is by default IPsec. So run interface G0/0. G0/0 is connected to, you can see here, internet transport, right? So if I will show you the running configuration of this interface, so run VPN0 on G0/0 interface, you can see encapsulation protocol is IPsec. And if I will try to configure the encapsulation protocol here, go to VPN0 interface G0/0 and tunnel interface, and then I will say encapsulation and put question mark. So you can see I have two options. Either I can enable GRE protocol or I can enable IPsec, and by default encapsulation protocol is IPsec on all the interfaces, right? So guys, what can be the value of T-lock 1? T-lock 1 system IP. System IP is what? 1.1.1. Encapsulation IPsec. In T-lock 2 also system IP is going to be same. Encapsulation is also same. IPsec only. IPsec. How we can differentiate the T-lock of internet and MPLS?
By using color.
right? So system IP is same, encapsulation is same. So color is something which is going to differentiate the transport. Color is something which is going to differentiate the transport, right? On G1 interface, right, I can configure different color. On G2 interface I can configure different color. For an example, on internet transport I have configured color internet, and here I have configured color what, MPLS. So now you can see both the T-locks are different. And guys, two T-lock cannot be same. Can two next hop IP address same? No, never. It is not possible, right? Next hop is a unique IP address. Two next hop cannot be same, right? In the same way, two T-lock cannot be same. T-lock is always unique. And how T-lock is unique? With the help of color.
Color. In case if I have two MPLS and one internet connection, how to differentiate this?
You can configure color A, color B.
Oh,
You can
color
configure red,
A.
blue, red, green,
Okay.
right? So we will configure a unique color on each transport. If I have 10 number of transport, on each transport I am going to configure different color, and color is the only thing which is going to differentiate the transport. Otherwise system IP and encapsulation protocol is exactly same, right? If here maybe this vanished device is connected to another transport also, Ethernet, Metro Ethernet, I can configure different color there. So by default, your vanished devices don't know the transport. When my vanished device don't know this interface is connected to internet or this interface connected to MPLS. They don't know. We are going to configure the color over here. Okay. If I will show you the color on G0/0 interface. Here encapsulation and then color. Color. See. These all colors are there. Biz internet, blue, custom 1, custom 2, custom 3, default, gold, Metro Ethernet, LTE, MPLS, public internet, red, silver, private 1, private 2, right? So many colors are there. We can use these colors to differentiate the transport, right? In my case, I am using two color. One is biz internet, one is MPLS. I am using biz internet for internet, and I am using MPLS color for MPLS. So here you can see on G0/0 which is connected to internet. What is color over here? Is internet. And then I am using restriction keyword here. But here I have another vanish device. Let's say vanish 2. Can this vanish 2 reach to vanish 1 with the help of T-log, guys? If let's say vanish 1, this is vanish 1, vanish 2, vanish 1 is advertising one LAN subnet 10.1.1.0/24 and 2 T-log 1 and T-log 2, right? Through VA Smart, vanish 2 device is going to learn it. But can vanish 1 forward traffic to this subnet? What is the information inside T-log? System IP, which is again not routable. IPsec, through IPsec I cannot forward the traffic color, right? So still next hop IP address is not there. Correct? In the T-log, next hop IP address is not there. Through T-log I cannot reach. Stop advertising next hop IP address, I am advertising T-log. Right? But through T-lock, how vanished devices can reach to other side? And guys, here is the benefit of advertising T-lock. Let's say here right now IP address is 100.1.1.1. What if the IP address will change here? This was the IP address yesterday, and tomorrow my IP address is 200.1.1.1. Again, I have to advertise my next hop IP address, right? So here is the benefit of advertising T-lock instead of advertising the IP address. In SD-WAN, we are not going to advertise next hop IP address. What we will advertise? T-lock with prefixes. What can be the definition of T-lock? We can say T-lock is something which identify the WAN is physical underlay interface, right? Or you can say transport interface, which identify the transport interface on WAN devices. If a WAN devices has two transport interface, that means there are two T-locks, so on. And T-lock is combination of three things. Three tuples are there. System IP, which is unique identity. Encapsulation is used for tunneling, to form tunneling. And the color. Color is identifier of transport, right? And again, there are two types of color: private color and public color. Similar like private IP, public IP, private ES, public ES, private port, public port. We have two types of color. For private connection, this is just a recommendation. By the way, you can use any color, right? Recommendation is for public transport, like internet is public transport. So here I should use public color. MPLS is a private connection. I should use private connection over here. So private colors are there like Metro Ethernet, MPLS, etc. Public colors are there like Biz Internet, public color, green, red, silver. These are public colors. Here till here. See, in this topology, in the DC I have one managed device and the LAN subnets are 192.168.100.0/24. 100.0/24. I am going to show you these subnets in, let's say, branch 2, side 2. Here I will show you the prefixes, DC prefixes. So IP route, let's say 192.168.100.0. Here is 100.0. Here is 192.168.100.0. How it is learning? Through OMP. And what is the T-log? 4.4.4, Biz Internet and IPsec. These are the three informations. Means T-log is here only, right? How it is learning? Is it visible, guys?
Yes, yes, yes.
Yes.
So see, from the DC some prefixes are coming in VPN 10. Don't worry about this VPN. 192.168.100.0/24 through OMP protocol, and this is the T-log. In the T-log there are three information. T-log there are three informations. System IP, color, and encapsulation. Right? Now to find the IP address, next hop IP address to reach in this subnet, Now my vanished device is going to check this till. We'll open it in, right, 4.4.4 system IP of the router who is advertising this subnet is 4.4.4. In the DC, I think only biz internet is there, but for any other prefix you can see, for an example 31.0. So 31.0 is coming from 2 TLOC. One is biz internet, one is MPLS. System IP and encapsulation is same, but the color is different. So from 2 TLOC are coming, right? That means 2 next hop IP addresses are there, right? And if you will open the TLOC of 4.4.4, so OMP TLOCs. So here you can see the TLOC of 4.4.4. What is the private and public IP address, guys? Here is the private and public IP address through which I can reach to 4.4.4, right? So inside the TLOC there is private and public IP address. If you are using public IP address on vanished devices, then public and private both the IP address is going to be same. If you are using private IP address on your vanished devices and you have NAT device, then private IP will be different, public IP address will be different. In that case, vBond is going to help. Get till here. Any question?
So at the moment, okay. So we'll watch this video again, and maybe next class we can ask some questions regarding this.
Yes, sure. Anyone have any question? Please ask. Otherwise, in the next class, we'll revise this topic. We'll discuss more about TLOCs, and then we'll see what best path selection. Best path selection of OMP. In the OMP update message, actually it is sending TLOC, origin code, originator, preference. Preference is similar like BGP local preference. Service route, site ID, tag value, VPN. So these are the attributes for best path selection. Okay, so in the next class, we'll see the best path selection of OMP, and after that, we'll start implementing SD-WAN in the topology. Either we can use same this topology from the scratch, or I can create the another topology. Right, so I think topology is fine. We can have same topology, configure it from the 0 from the IP addressing.